Good morning, everyone. Today we are going to just kind of recap slope a little bit. So slope describes the rise and the run of a line. If we have a positive slope, which we talked about this last class, it's going to go from left to right, increasing up like this. If it's a negative slope, it's going to go down when you look at it from left to right. If we have a slope of 0, it's a flat horizontal line. If we have an undefined slope, it's straight up and down. Okay. The last two classes, we talked about these first two ways to find slope. We talked about from a graph and from 2 points. Excuse me. So the first thing we do when we're trying to find slope from a graph, I'm going to zoom in a little here. First thing we do to find slope from a graph is we find 2 distinct points on the line. I see that this is definitely a point and this is definitely a point. Then we count the rise and the run between the 2 points, and we write it as a fraction. So I'm rising 1, 2, and I'm running 3. So I would put 2 over 3, and that would be my slope. Okay. I can't reduce that, but if I could, I would try to. Last class, we talked about slope from 2 points. The first thing you have to do when you have 2 points is label x1, y1, x2, y2. So if I have these 2 points, -3, 2, 5, -4, I'm going to label them x1, y1, x2, y2. The next step is to substitute the numbers into the slope formula, which is y2 minus y1 over x2 minus x1. Remember that m equals slope. So I'm going to go ahead and do that now. So m should equal y2 is -4 minus y1 is 2 over x2 minus x1. And I'm subtracting a negative, so that's actually going to change to a positive. Now I got to reduce, so I have -4 minus 2 is -6. 5 and 3 is 8. So I just simplified that fraction. Now I can also reduce it. If I divide both of these by 2, I get -3 over 4. And that is going to be my slope. So those we talked about in the past 2 classes. These are some new ways to find slope, one of which we kind of threw at you yesterday. So the first one is from a table. So if you're trying to find slope from a table, just choose any 2 points from the table, label it x1, y1, x2, y2, and then we just substitute the numbers into the slope formula, which we just talked about. So I'm going to go ahead and choose the points -6, -2, and -1, 2. I'll just choose the first 2 points. So this is my x1, y1, x2, y2. So now down here, I'm going to plug it in. y2 is 2 minus y1 is -2, so that's going to change this to a positive. And then I have -1 minus -6. That's also going to change to a positive. So I'm subtracting a negative. That gives me 4 over 5. I can't reduce that anymore, so just my slope would be 4 over 5. The other way you could kind of look at a slope from a table is you look for the change in x, change in y over the change in x. So from here to here, what's happening from -6 to -1? Well, from -6 to -1, I'm adding 5. From -2 to 2, I'm adding 4. So my change in y is 4 over my change in x is 5. So see, I get the same answer. Okay, so whatever way kind of works better for you at the table. The last thing is finding slope from an equation. So if we solve for y, if necessary, so sometimes you might get an equation that looks like this. You have to get y by itself so that it's in slope-intercept form, which is that y, I think I'm going to write it right. Nope. y equals mx plus b is my slope-intercept form. So you always want it to look like that. So if y is not by itself, you got to move that that 2x over by subtracting it. Identify m, hint, this is the coefficient of the x. So it's whatever value, whatever number is in front of x. This is the slope of the function. So if I'm looking at this equation right here, write the coefficient of x right in front of the x is -2. So that's the slope of the function. So really the equation here is this. The slope-intercept form is this, with m being the slope. So you just should be able to see that these are in the same location. Okay? All right, so you guys are going to try some problems on your own similar to this today. All right, have a great day.